Thank you, Isaiah. So Pythagorean Theorem in the Converse and classifying triangles, like I already spoke to you. If your numbers don't satisfy the equation of a squared plus b squared equals c squared, then it is not a right triangle. It's one of the other two. It's either acute or it's obtuse. One, we are recording. So, the way to look for the other two. If your c squared is less than a squared plus b squared, then your triangle is going to be an acute triangle. If your c squared is greater than a squared plus b squared, then your triangle is going to be obtuse. That's how you figure out if it's acute, right, or obtuse, based on how it satisfies the Pythagorean theorem. So a couple things down here. Always keep the c squared on the left side to avoid confusion when classifying. Directions first. Determine. This is the first thing you need to do, and we've already done this before. Determine if the three side lengths could form a triangle. Recall from earlier, meaning earlier, something I taught you before. The sum of the two smaller sides must be greater than the third side. It has to be a triangle first before you even do the Pythagorean theorem. So then, if yes, classify the triangle further as acute, right, or obtuse. So I'm doing number one with you. First thing I want to check and see is that make sure that this is a triangle. Make sure that it's a triangle. I'm gonna do my two smaller sides, which is 3 plus 7. That equals 10. In this case, 10 is greater than 9. So for me, this is a triangle. It does qualify as a triangle. These three sides. If that's the case, I'm gonna check and see what kind of triangle it is by using the stuff up top. So I'm doing Pythagorean theorem, but I'm not going to put an equal sign or less than sign or greater than sign in the middle. I'm going to say c squared. I'm going to put a question mark there because I don't know yet. I don't know what it's going to give me. A squared plus b squared. Now, only thing you need to be right about is your hypotenuse. Even though they only gave us numbers, you should still know what the hypotenuse is. Why? Because the hypotenuse is what? You're not in my class. The hypotenuse is what? Oh, Jesus. We know that, sir. Thank you. I think Imani said it. The hypotenuse will be your largest side. So in this case, 9 would be my hypotenuse. So 9 squared, and then the other two, A and B, they don't matter. 3 squared plus 7 squared, because they're on the same side. You don't matter if you mix those. 9 squared, 81. On this side, 3 squared, 9 plus 7 squared, which is 49. Add those together, you get 58. And I get 81 right here. And then from there, I'm reading the side which sign I'm about putting there. 81 is what? Than 58. Greater than. Since 81 is greater than 58, what kind of triangle do we have? Look at the stuff up top. Obtuse. That is how you check to see if your triangle is obtuse, acute, or right. Doing one more. Number 4. I want to check to see if this is a triangle first. Before I even start, make sure it qualifies as a triangle. 17 plus 17 equals 34. 34 is greater than 22, so we're good. This is a triangle, so I can check to see what kind of triangle it is. C squared, A squared, B squared, C squared is 22. Let me ask you this, because I posed this last class. Let me stop and ask you this real quick. Just based on the numbers right there, we could classify this triangle based on these numbers, 17, 17, and 22. Classify it by its size. What kind of triangle is it? Thank you, ma'am. Isosceles. Somebody said right. Jesus Christ. Alright. Then from there we're going to do Pythagorean to see what kind of triangle it is as far as its angles. 22 squared, 484. 17 squared is 289. So 289 plus 289. And then you get 484 on this side. You get 578 on this side. 484 is less than 578. So this is an acute triangle. I want you to do 2 and 3 without me. Give you about 5 minutes. Shouldn't take that long. Oh. Alright. Goofy. The diagram shows a rectangle ABCD with diagonal BD in it. First thing you should notice is what kind of triangles they have inside of this rectangle. Based on the degrees, these are 30, 60, 90 triangles. That's the case. Obviously, they want you to use what you know about 30, 60, 90 triangles now to move around in there. They give you what, Juan? What side of the 30, 60, 90 triangle they give you? Hypotenuse. Good. You need to find a short leg and a longer leg. Short leg first, Juan. How you find a short leg? If you're given the hypotenuse. Divide by 2. Thank you. So, short leg is what? And then from there, Juan, we need to go from short leg, we need to get our longer leg. How do you find the longer leg? Good. So, that would be what? Thank you, Juan. This is very impressive, sir. So this is, and I'm being serious, see, he ain't got no hesitation in him either. 6 square root 3 at the top too. Y'all should all know both of those sides are going to be the same, and this side over here is going to be 6 as well. If that's the case, they want to know the perimeter of the rectangle. This is where a lot of y'all started messing up at. First, they said you could give your answer to the nearest 10, so you can't give a decimal on this one. But I'm going to give you it in simplest radical form first, just so you can see it that way, and then we'll convert it to a decimal. Simplest radical form would be this: perimeter equals, so we're doing 6 plus 6 plus 6 to the square root of 3 plus 6 square root of 3. You should have practiced this because y'all obviously didn't get enough work with this in algebra if you got any. But this is equivalent to showing you something like this: 8 plus 8 plus 8x plus 8x. If you saw this right here, what would you do to combine? I'm asking any of y'all. 16 plus 16x, right? Yeah. Same concept down here. You can only combine like terms. So what should this be? 12 plus 12 square root 3. And that's simplest form for this if you're going to keep it in radical form. Some of y'all are adding those 12s together. Y'all adding all the 6s. You can't add 6s that don't have that are not the same. Like 6 square root 3 ain't the same as 6. You can't add those together. You can't add one with a coefficient on it like that with a constant. Alright. So that would be simplest form if they ask for radical form. But they asked for the decimal, so we can work this all the way out. To work it all the way out, though, you got to do the order of operations. You can't do 12 plus 12 because that's not order of operations. You need to do this part first. You take square root of 3, get that decimal, and then times that by 12. What's my calculator at that you said you were going to bring back to me? This is not the one I wanted, but okay. Can I have the other one? Thank you, man. It's mine, but I don't want that one. So they take square root of 3 first. You're going to get that decimal times 12. And then you're going to add 12 to that. That should be an answer, which is... Oh, and they say around to the nearest tenth. So what are you writing? 32.8. So perimeter for us will be 32.8. And they didn't give us a unit of measure, did they? No. Screw it. Alright, like I said, number 10 y'all should be able to do on your own. It's a square. All you gotta do is find it's a square, so it's 45, 45, 90. You can't get no decimals on this one. This one should be in radical form. Y'all should be able to do that. They give you the hypotenuse, they're looking for the legs. Once you find all the legs, you can either add them together or you can multiply by 4. Get one leg and multiply by 4. But you need to put it in simplest form. Give you a second to do that, and if they come around to get my stuff.